So, guys, in this session, I'm teaching you predictive modeling. Predictive modeling means we are creating a model which return you the prediction. We are creating a model which return you prediction. So, question is this: what is model? Model is my algorithm, which takes the data, do perform the training, then return you the prediction. All right. Uh, First presentation, then implementation. So, what is predictive modeling? Let's see its definition. Then we move forward. Okay. Predictive modeling is a process of creating, testing, and validating the model to the best predict the probability of the outcome. The model is chosen on the basis of testing, validation, and evaluation using the detection of theory to guess the probability of an outcome in a given set of amount of input data. So, what data you are going to input? You have to train, you have to test, and you have to predict. So, what is the theme behind the training and testing part? Means from the childhood your parents your teachers going to train you. So what training you get, you feed your mind, because everything is driven from artificial intelligence. Everything is either it's a data analytics, machine learning, deep learning, reinforcement learning, everything is subset of that. So artificial intelligence is, I am making the intelligence artificially. So how do I put this thing? We put this thing with the help of training part, and then when do the training, then we also check the test. Why test? Because we have to evaluate our model. That's why. So model can use one or more classes in try to determine the probability of. Why we use the probability? Because it's a general definition. Okay. The When we build a model, so different criteria to evaluate different model. All right. So we will discuss in presentation. Determine of set of data belonging to another set. The different model available on the modeling portfolio for the predictive analysis software enable us drive a new information about the data and how to develop the predictive model. So thing is that the predictive modeling is a technique by which you build a model, put your data, train the model, test your model, find its errors, accuracy, and then you got the prediction. Based on their accuracy and errors, you can decide how best your model. Means the prediction given by your model, how near the real value. Okay. Somewhere see, somewhere you any one of you are interested in a match, cricket match. So any cricket between Australia and Pakistan going to be. So what happened, there is a prediction 80% chance of winning in India. So how they got the prediction? They got the prediction from the previous data, because they got the data, they train the model, and everything you got over here. Okay. So in predictive analysis, what we do, we have data, we analyze the data, monitoring the data, then do the predictive analysis. What it return? What is going to happen in future? So clearly, you got the prediction. What happening now? The monitoring says, and report says what happened or what happened previously in the past. So these three phase is corresponding each step, but we are concerned over here what happening in the future. Okay. So the first algorithm, the algorithm concerned with the linear regression. All right. So here I'm trying to demonstrate you the linear regression. Then I will make a model based on a given data set. All right. So you guys, meanwhile, you can download data set, given link. If someone late join, uh, if someone late join, so no, I will even join over here. All right. Okay. So let me mark the attendance. Mm, perfect. All right. Now, what is linear regression? Very good thing. And the first step towards a prediction, linear regression. What is this? A linear regression is one of the easiest and most popular machine learning algorithm. See, it's a completely belong to machine learning. But why we use this is in data analytics? Because we have to see the predictive modeling. So first thing we have to check about the regression. In the simple words, regression shows the relationship between two variables, how the dependency of one variable or outcome variable to the input variable. Just like for simple example, If you do study 10 hours to 15 hours, you will score very good in examination. If you study 0 hours, means no study, or 1 hour, you'd score less, except the exception. Okay, so thing is that your number of hours makes your marks good. So marks is an outcome thing, the input thing is the number of hours studies. So you find over here the one input parameter creating one output. All right. So what happened with this? You can easily calculate the relationship between the number of hours and the marks obtained by you. Okay. So sometimes what happen? Not a single input can play important role. Many other things play important role whose output we get. Extending this concept, which concept? The marks obtained concept. The number of hours studied, the number of hours you playing, the number of hours you sleeping, your attendance will makes how marks you are obtaining the thing. So you see, first we have only one parameter, then what we have, we see the multiple parameter employed this way. The multiple parameter play an important role. So linear regression can be divided simple or multiple. In single or simple, we have only one input, and multiple, we have multiple input and one output. Okay, so linear regression makes a prediction for continuous real or numeric variable such as sales, salary, age, product, and price. Keep in mind the regression return you the prediction in the numeric format. Okay, so when we got the prediction, we can classify prediction three types: regression, classification, and clustering. So this is a one type where you got only numeric one. In classification, you got the numeric prediction, but that it is a non-continuous variable, means that is a repeated variable, means that column is categorical. Just like if you consider the diabetic data set, so column is outcome column contain 1 and 0. That is also numeric, but that is a repeat is means categorical variable. Means they are classified variable. But here in regression, you don't have any classified variable. Every rows has a unique value. Mostly. Okay, maybe it may be repeated one or two times, but not so much, just like in classification. So linear regression algorithm shows a linear relationship between the dependent, this is one word, or we can say outcome or dependent, and one or more independent variables. Hence is called the linear regression. Since linear regression shows the linear relationship, which mean to find how the value of the dependent variable is changing according to value of independent. Means if you put more hour of studies, so what will be your outcome, means percentage of marks. If you put the less hours of study, so what is your percentage of marks? So again repeating, the linear regression shows the linear relationship between, sorry, which means to find how the value of dependent variable is changing. The dependent variable means outcome changing according to the value of the independent variable. All right, so here the relationship is there, one is changing, input is changing, so this will surely impact on the output. So that's the thing we have to analyze this. All right, so this is some line chart. This shows some relationship between independent and dependent. See, this x-axis known as the independent or inputs, and y-axis known as dependent or outcome. Okay, why we say it's independent? Because the line of equation which shows the y equal to mx plus c, y equal to, we have to feed the value of x, we have to feed the value of m, that is slope, and we have to feed the value of c, that is intercept. So going to previous slide, what happened here, you can see the trend, you can see that trend over here, means if we increasing the value of x, so y is increasing. So in regression we find a regression line, predictor line, and this line try to cover the maximum point. See, one line cannot cover the all points, but it can cover the maximum point. So what is the reason behind this? So how much point it will cover, it will generate the less error. How? I will show in this session. Okay. So this line known as the best fit line. Why best fit? Because it's trying to cover the maximum point. All right. So it shows the relationship between this using the slope. So Three term laws are there. One is slope, x value, and c. So y known as the dependent, because using the value of x, I am calculating the y. Until you don't have the x value, you can't calculate the y. At least you have at least x equal to 0, so you can condition to calculate the y. So y is dependent on x, m, and c. So these are the y is dependent variable, or it is a prediction. Our technology word, it's a prediction. M is a slope. What is slope? Slope is a rate of change of rate of change of y with respect to x. Means for a unit, if we are traveling toward here to here, so to traveling here to here, what amount of y is changing? Means y2 minus y1, and what amount of x is changing? So it is also known as dy upon dx, del y upon del x. Many form is there. So ultimately, thing which we have to point, the rate of change of y upon rate of change of x. That is known as slope. So how much slope is there? How steep slope is there? So that was kind of rapidly changing the outcome variable. Second thing is c, intercept on y-axis. So that is also known as a bias term. What is bias? If my student nothing attempt in their notebook, if my student nothing attempt, no question or zero question, a blank book it is putting over there, and beside I am giving the 10 number, beside I am giving the 10 number, so it means I am biasing towards that student. My evaluation criteria is not good. So if you put simple x equal to 0, so y should also be 0. If y is not 0, it means c have any value. So a good model, it is recommended the line should be passed in the origin. The line should be passed on the origin, means x0, y0. That is a good condition. But never it happen in real world. You have some biases over there. For having these biases, you can easily calculate the prediction. Okay, a bias is also known as the coefficient of line. All right. Now, checking some example over here. We have rainfall and we have crop yield. You know how much good rainfall is there, that much good kind of crop predictions, crop yield. Okay, so I try to put over here some trend, some data points which show some linear line. Okay, if you want to fit over there, you can find over there. So this linear line will show the relationship between the rainfall and the crop yield. So this shows some positive slope. When the line trending toward this, that is a positive slope. Line trending towards parallel to x-axis, that is zero slope. Line toward this one, that is negative slope. Okay, so if for any value of rainfall you want to know, so either you go to calculate the y value, so you find the m of this line, slope of this line, you find the intercept of this line, and you find the x value for this line. Then you can able to calculate the y point. If you don't want to do this thing, so draw the perpendicular on a line for which value it is accepting this line of y. You can draw the perpendicular on y axis. So for this regarding of x axis value, you will find the y value. So thing is that here I'm trying to show you how to draw the modeling, how to fit a best fit line, so that we can put any input and we can put its output. So red line on y axis, which one? This is the amount of crop yield, and you can expect this for some amount of rainfall represented by the green dot. Means if this much kind of rainfall, you get this kind of outcome of copy, because your model get trained, means your algorithm get trained. Why trained? Because the best fit line is presented, generated, then you can able to see this kind of thing. All right. Now let's consider this thing with the help of data set. So check this one. I will use one method, least square regression. Okay, why we use this method? Because we have to ultimately find m and c of this line, because here we are automating this thing with the help of mathematically. We are not using any programmatically right now. So at least I need to calculate M and C. So I will navigate to one more website, Math is Fun, which I use in last few classes, and use the least square regression, which give me return the value of N and C with the help of formula. I will demonstrate you formula, demonstrate you numerical examples so that you have better understanding. Okay, before this, we have one data set. Let's suppose this is inputs or independent variable, this is output or dependent variable. So we do plot this thing. Check this one. For x equal to 1, we have y equal to 2, x equal to 2, y equal to 4, x equal to 3, y equal to 5, like that. So you point over here, no point in a linear line. If you want to try plot a linear line, so you can pass over here, mostly 3 points cover, or you pass over here. Okay, so maximum 3 points going cover. But what happened if we put the line over here? So what this point do? What this point created error? How to point create error? I will show you very shortly. Okay, so ultimately think the reason behind this to train a model to produce a best fit line which nearby the all the point maybe cover or it's a nearby all the line. Okay, so first I draw this line. In second way, I get assumption. What assumption? Regression lines ideally pass through the mean of x and mean of y. So assumption says that everything is true, everything is fine. So the line should be ideally pies the mean of x. I take all the value and divide by the 5 because these are 5 number. Similarly, I take all the value, divide by 5. So we get 3 comma 4. 3 is a x coordinate and this one is a y coordinate. Okay, so what happened? Expected line that is shown in yellow line pass from 3 comma 4. Okay, but question is this, how to calculate the m and c value? Someone is entering my class. Yes. Okay, so how to calculate these value? Okay, so we have to take the help of least square regression which help you to get the value of m and c. So this is from least square regression. Don't be panic, I will tell you everything neatly and cleanly. So I'm navigating the external site, math is fun, least square regression. Math is fun, least square regression. Okay, I have external link also of this one in my slide. All right, see this example, very good example. What it do? It find the line of best fit. Okay, this kind of line. But how do it find? That's a question. First of all, it assumption, take the assumption of the equation y equal to mx plus b. B and c are the same thing. That is intercept. Y intercept means intercept on y axis. So don't be bother. What is b? What is c? That is the same term. M is slope, x is the input, b is your intercept. Okay. So let's take in a formula. These are the steps. We come back with on these steps one by one. Okay. First, we understand the numerical problem. We have a numerical problem. What numerical problem? If we have X hours of sunshine, so how much my ice cream is sold out? The, the problem talking about the summers. So lots of summers, so lots of people taking the ice cream. So they try to establish a relationship between sunshine and ice cream. So how they find the slope of line M and how they found a C. Okay, the step I miss over there, I will again come here to do one by one. Okay, so using this numerical, I draw a table. The first step is first you tabular the x and y, what data you have, then calculate x square and xy, x square and xy. So what is x square? What value you have of x? That is x square. And what you xy? When you multiply x into y, you got the xy. Okay. So the first step for least square regression for calculating the m and c, do prepare this kind of table where you have to put the x square and xy. Now what you have to find? You have to calculate summation. Means summation x at this column, summation y at this column, summation x square at this column, summation xy at this column. And how many number of data point you have? You have 5 data point. Now, in second step, you create this one. Now, what about the third step? In third step, we have formula. There's a predefined formula of least square regression to calculating the slope of line. N is my data point. Summation xy means summation xy. So 5 into 263 minus summation x into summation y, 26 into 41. All right, upon n into x square summation. So 168 over there. Now see the difference. X square summation, summation x whole square. So this is a term of this one. When you put all the things over here and solve, you find the slope over there. Fine. When you find the slope over there, so you have to find the intercept of B or C. Yes, please. What's your good name, dear? Yes, Avidash. Yes, please.
What this formula represent? M. We calculate randomly like by using this. Like this is like covariance by standard deviation, right? M.
Mm, not sure. I mean, I'm not derive this formula. I just
You
work on this
saw
formula.
the yesterday like that there's covariation of xy divided by the standard deviation of x, right?
Mm-hmm,
N is like omitted.
mm-hmm.
This
So,
formula.
I mean, I'm not getting a question. This formula contain some previous
No,
formula.
actually, sir, you are saying like we calculate in this way to get this m, but what actually m represents? Like this is the actually I think like this covariance by standard deviation, right?
Uh, mm,
Covariance of xy divided by standard deviation of
Covax,
x.
yeah, definitely you can nearby that thing, this thing. But I never point out this thing. I just take this formula and calculate. See what lines are there. So best fit line represent what amount of m, what amount of slope of this line means whatever point you are given over there. Based on this point, the line drawn over there, what kind of slope is there? That is representing.
Okay.
Alright, the data given over there. Check this one. This data given over there. If you want to calculate the slope, put the x value, y value, something that you got a best fit line. I don't know I mean, we don't know yet what best fit line is until you don't use the value of m and value of c. When you have value of c and value of m, so you got some point over there, uniform point, and these point in line because these are calculated point. Then the line drawn on this point, because keep in mind, uh, all the points on the line are the predicted point. All right,
Okay.
so the intention behind this to calculate the m, to draw a best fit line. Similarly, the least square regression use another formula to calculate the c. All right, so what happened, we have to use again the formula summation y m into summation x upon n. It is explicitly given over here because that's why it's algorithm using very much for the formula of y. So when you have a c, sorry, when you have a m, so you can also calculate the value of b or the intercept over there. So what advantage of using this m and c value? Okay, we have ready-made equation. I put the value of m, I put the value of c. So what is remaining? Remaining is x. When you give the value of x, so the predicted value of y you got. Check this one. This is x. Say y. This is your ready-made equation. I put here. I put here slope. I put here the intercept. All right. So you have actual value. You have predicted value. So using this thing, and this line always is straight line because you have constant m, constant value of b, and you have x. So when you calculating this thing, so you got all the point in a straight line. Check this thing. The black line shows the calculate thing. And see the previous behavior. Previous behavior. In previous data point expanding like this. But here the data expanding like this. I mean, sorry, my hand is curvature. So thing is that behind. So you got a straight line over here. Okay. Now I'm navigating to my previous thing. Previous slide. I mean, what we are. All right. So same thing is evaluating over here. Same thing. What they do, this is just Least square regression, x, y, x square, x, y. The formula of m, n is the total number of data point, everything. So you find the value of m equal to 0 0.6. While you're putting the value of m over here, you find a slope over here. Okay. So what they do, they create a equation. They create a equation y equal to mx plus c, and they getting the value of x equal to 3. When they put the value of x equal to 3, so they return the y equal to 4. So my question is this: why they put the value of x equal to 3 only? Even we have 1, 2, 3, 4, 5. So why they put only 3? Because in the previous slide, it's assumption that we have passed our line mean of x and mean of y. So my equation is completely valid. When you put x equal to 3, you got the y equal to 4. Perfect. Means the validness of equation is my good, slope is perfect, and the intercept is perfect. Because you're putting the x equal to 3, you're returning the y equal to 4, and ideally lines should be passed on 3 comma 4. Sorry, 3 comma 4. Got it? So by this way, your slope is perfect, a given line, your intercept is perfect for a given line. All right. Now, what we do? This is very important slide. Okay, you have to see everything over here carefully. Now, we have two things. We have actual value, we have predicted value. So actual value shown in blue and the predicted value shown in brown or yellow. Okay. See what it do. It generate the equation. In equation, slope is constant, intercept is constant. So what changing? Changing the value of x, 1, 2, 3, 4, 5. Regarding changing the value of x, you got the change in y. That is your predicted value or calculated value. So let's find out the predicted value of y corresponding the value of x using the linear equation where we have m equal to 0 0.6 and c equal to 2.2, which is calculated from the least square regression. All right. Now, here the blue points represent the actual y value. Blue points, actual y value. And the brown point represent the predicted y value. Why they are in linear? Why not curvature shape? Because we calculated, we put the constant slope, we put the constant intercept, and we kind of linear kind of shape. Check this one. Now one thing should be clear, that your predicted value may be less than the actual value. Check this one. Here the actual value is high, that is 4, predicted value less, and your predicted value is greater than the actual value. All right, your predicted value is greater than the actual value, and sometimes your predicted value is less than the actual value. Okay, so the distance between the actual and predicted value are known as the residuals or errors. Sometimes the distance known as the residuals or errors. The best fit line should be have least sum of square of these line known as the e square. So one term is coming, least means minimum, sum of square of these error means we are doing the difference, we are calculating the difference. Why difference? Because we are calculating the errors. Taking the errors, we are doing a square. Why square? Because negative and positive error don't be cancel out each one. So which m and c value represent least sum of square error, that is a perfect m and c for you. Okay, when we do this thing with the Python, so my scikit-learn library calculate this thing for me. Okay, they will explicitly present this thing over here. All right, now check this one. How with you are doing x value, y value, y pred. Pred means that value getting your from formula. Then difference actual minus predicted. So some difference coming in minus and some in plus. So if you add directly, so minus and plus value cancel out each other. Sometimes they say there is no errors. When you squaring of this one, then you adding. So this should be minimum for a best fit line. Okay. So model always select the good value of M and C That is also known as the problem of gradient descent, means where your gradient going to be descent. Okay, that is a part of machine learning. Okay, how the manually thing are checked for the M and C if you're not checking the formula of least square regression. That in that case we focus with emphasis on the gradient descent. But for here you have to keep mind that these squared error must be the least one. All right. Now, what happen if we are not getting the best fit line? See, we are trying to achieve the best fit line. What happened with this? What happened? We randomly draw a line. Now we start moving the line and calculate the distance between the predicted and actual one. Check this one. We tilt the line, calculate. So this value of M and this value of C will give you uh, some of a square error, some amount. Maybe this is best or worst from this condition. This is previous, this is current. Means this line keep moving until you got the minimum value of M and C. So when you got the minimum sum of square error, so that value of slope and that value of C is better for you, because your point which are sometimes actual points, sometimes above the prediction point and sometimes the actual point below the prediction point, generating the least error, less square error. That's why we emphasis on this one. All right. Now, when we have only one input, just like I told you example very beginning, that when you have the number of hours studied and you are calculating the output, how much student is scoring. So you gone through what happened. You gone through only the simple linear regression. But if you have individual in multiple input, one, two, three, four, five. So what happened? You go know the multiple linear regression. Means your output marks is dependent on your attendance, your number of hours study, number of hours playing, number of hours sleeping, like that. So you have this kind of thing. So real world thing, many comes across this kind of way. All right. So we can have a use case, we can predict the expenditure, we can predict the profit of linear regression. Keep in mind when we are going to predict any numerical thing. So we have regression problem. Keep in mind when we have any label thing, label means male female, means diabetic non diabetic, then we have a classification thing. Okay, and when we have dividing the data into groups, that's for clustering. Okay, now how to evaluate your regression model? We have some criteria. First one, mean absolute error. Mean you are taking the absolute value then taking the mean. What is absolute value? Means subtracting a number and taking the numeric value, leave the sign. Absolute means if you have 3 minus 5, then absolute, so it is not giving you minus 2, it is giving you plus 2, because absolute remove the minus sign. Okay, so ma is a mean absolute of errors. It is calculated as 1 upon n, actual minus predicted, mod means absolute, this is a mathematical function, mod absolute, gathering all the point and divide 1 by n, means how much data point you have. What you do is just directly take the directly distance, directly errors from actual minus predicted. Same way, if you want to take mean squared error, so what it do, it will just square the error. Why we present the box? Because the vertical distance get squared. All right, so the mean squared error is the mean of the square error is calculated, actual minus predicted, square, sum them all and divide by total number of data point. This is mean square error. Then we have one more, root mean square error. When you're doing the square, so it is a good amount. But why we doing the square? Because just removing the negative sign. Then if we want to do this thing, see average how much do thing, average how much data point is generating error. So what we do, we take square root. All right, that is known as root mean square value, is root mean square error. Mean square error get under root. So actual minus predicted, then get square, then sum them all, then divide 1 by n, then take the square. One more important thing, R2 score. All right. So what it do? R2 score determine how well the regression prediction approximate the real data points. Where y hat, see many times this symbol you find over there. This symbol known as the predicted point. This symbol average point. Keep in mind this is a conical shape or flat shape. Okay. So y hat represent the predicted value of yi, means yi means for any given data point. I means any row, for first row, second row, third row, and y dash is a mean of the observed data which is calculated as like this one. So what I do over here, 1 minus summing all the point after get subtracting the prediction, taking the square, upon summing all the point, y minus this one. The one important thing about this one, this have the maximum value of 1, minimum 0. So how close you are 1, that is your good model. Generally any model which is greater than 70% show the, I mean, 0.70,
Sir,
0.70. Yes.
sir, y bar is the mean, right?
Yeah, y bar is mean and that is
Then
predicted value.
the formula should be 1 by n.
Yes, sir. It is wrong actually.
Okay, okay, I hope maybe I get from the it's Google image maybe. So where is the correction? 1 by,
Yeah,
Sir,
in y bar equal to summation I equal to 1 to n yi by n.
sir, one thing given over here, I
Yeah,
think.
yeah,
should be multiplied by 1 by n, sir.
multiplied by yes,
Mission.
multiplied by 1 by n.
Y bar is multiplied by 1 by n.
And the
Not
R
that.
square formula is right, but y bar formula is
Okay, sir. You are not dividing all the data points by the
No,
total
okay,
number
okay, that's good. Okay, okay, okay. I mean,
observed.
you are talking about this one, no?
yeah,
Yes,
yeah.
sir.
Actually, these are different two sources.
Other thing,
That's
sir,
that's why.
I need to add, sir, these R square. Why we doing minus from one? Because R
Bec-
square is that sum of co-education by sum of total.
This is
Uh,
R2 score. Basically, somewhere it is R2 R square. Basically, R2 score is written over there.
is the
Basically,
coefficient of determinant.
yeah.
So why doing that one minus this thing in that form?
Actually, it's a formula. You never gone through the documentation of scikit-learn of R2 score. Please wait. I'm
No,
just showing.
actually, as the formula says like
Eh,
that these two things divided. Why we
eh,
doing minus?
just wait here. Let me check the thing. Somewhere I put the wrong image. Please wait. Somewhere. I mean, I got the images point. Somewhere formula. Where I got the formula. Perfect.
The R square formula is right, what is written over there. But
Okay.
um,
So where is the problem?
sir, can you show me?
Slide.
Yeah,
Ha.
yeah, y bar. Uh,
Only Viber. This one is here.
yeah, only one. Yeah, yeah,
Okay. Okay.
1 by n. It's supposed to.
Okay. No problem.
Here, all things are cancelled out
Hmm,
with
hmm,
the
hmm,
one.
hmm, 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 hmm. You
So it is
mean please take care of this one. Actually, a lot of times take
yeah, I did.
divide by n. All right, take this one. Y bar equal to y by n. All right. Okay. So this is another way. Uh, this basically used to how to good model is how good model is my regression. The previous thing shows you error. So how your errors tending to zero, that is a good thing, but how your model tending to accuracy. Okay, because one is shown for 100% accuracy. Okay, so that is used for this one. When we do plot the regression chart of actual and actual and predicted, then you find how close the predicted value to actual value. If your actual value is not close by this thing, so you have worst model. At least 65% should be returned by this one. Okay, next remaining thing up to data set. What data you have, good kind of data set you have. Another way that is I hope you not understand the cross validation. Okay, if this R2 score is not good for your model, so we take cross validation. What is cross validation? I just give you the summary. We divide data into folds. Fold means we divide data into parts. Parts means 5 parts. Then we check in which fold my data shows the highest accuracy. So R2 score play an important role when we do the cross validation, because the fold by fold, that's we have 100 data points and we divide data into 5 folds, means 20 point in each one. So we can check R2 score which segment of data set have a good data. But the alternative approach we use in scikit-learn library, there is train test split. What train test split do? Train test split dividing data set into training and testing part, but they shuffle data set. So why they shuffle data set? So that if you checking the outliers like that thing, or bad data, or that data that has no significance, that is mix up the good data, means average, the model will give you not worst, not good, it will give you average prediction. Somehow it is nearby the reality. That's why we do shuffling. I mean, that's why train test split function do an important role. Okay, so how many of you actually I put many links over here. One link is math is fun for least square regression. You find over there and read the complete block. Okay, so how many of you have the Jupyter notebook right now, so that we can, how many of you? Okay, so we can create a model. Okay, so meanwhile you can download the zip file. I give you one link, again pasting this link to you. Mm, Again pasting this link to you. Go there, whatever, this is a link for you forever. Okay, so you can access the Google Drive, this kind of user interface there. Downloading the housing data set. Okay, create a file and I download the housing data set. Okay, okay, so put them in folder. Meanwhile I am starting my Jupyter notebook. All right, so creating a folder. How to create a folder? Click on the new. Okay, then rename this regression. All right, I'm uploading data set over here. Okay, let's have a look what inside the given data set. I just download before you. Uh, Open with, not open with, only save the file. This is Firefox. I use the second browser. Extract them over here. Extract here. So we have file folder. Control C. I put this folder before you. Mm, Check this one. What file it have? It have two files: dot data and dot names. All of you extracted the file. Savisachi, do with me. Okay, all you extracted file. Savisachi, are you doing with me?
Yes, sir. Yes, sir.
Okay, okay. Extracted the file. Let's see what inside this one. First, open the data. Maybe this is not open. You need Notepad plus plus software. You need Notepad plus plus. Otherwise, Jupyter will open this Notepad plus plus file. Okay, plus plus software. Okay, if it is not opening that directly in your text file, so open with this thing in the Jupyter. It will open this file. It's like click on the data. You find here data columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 prompts are there. But one thing, they are not separated with the comma, they are missing with the header name. Okay, so what we do, we just take new Python, take a new Python file, regression model. Okay, so import all the libraries, import numpy, snp, take all the things in one cell, import pandas, pd, import matplotlib dot pyplot splt, import cbon sns, import warnings, warnings dot filter warning, and that is ignore. Run these all. Any typing mistakes? Let's check. Oh, perfect. Right. So I putting this thing to you. You can copy. All right. So this data file have three. Okay. So what is our second file? Dot name file. See, whenever you download some data set, so you from UCI machine learning side, so you have to for download two files. First dot data dot names. What this contain? When you open in Jupyter, so this will give you the data, the information about the data set. This is Boston housing data. Okay, it can the information given about the researcher, but this is not our concern. Our concern is start from the here. Point number five. How many rows are there? Good, 506. How many attributes are there? 13 plus 1. What are the attribute name? What are the column name? So first one is crime. So the researcher who created data set uh, take some parameter which enable us that when we are going to take a house in a particular city, so what are the factor which decide this thing? So the researcher take the crime as a good factor. You know, when any city is a highly crime city, so no one want to live in that city, so house price automatically decrease. One is very good factor is river, Charles river. Okay, so what happened this one, it contain the binary value 0 1. So what happened in the ancient history? You found that when any city is going to be established, the all major city side by the any river. You can check Delhi side of Yamuna, Lucknow side of also Yamuna. Okay, so every city, every big capital of different countries. London is side by which river? GK question. London is side by which river? Good. Okay. And Washington DC is side by which river? Yeah, yeah. Muhammad Usman live in Egypt. Okay, so that is not our concern or GK question. The thing is that researchers take their transportation medium because initially there is no railway, no bus, cars. So that rivers is considered as a transportation medium. So they say if any city alongside the rivers, that is an ancient city, they are initially very earlier developed. Okay, again, take any one of parameter NOx, nitric oxide, highly polluted city. It take one good more parameter, that is age. If any city more aged person is living, so what happened with the old person? They are trying to leave the city because they want to settle down there by children. So they will sell their house as soon as possible, something bargaining price, and that take PT ratio, people teacher ratio, just like, and how many teacher, how many student one teacher is there? There's 1 to 1, 1 to 40, or something else. And at last, after getting these 30 parameter, it gives you the median value of owner occupied homes in $1,000. Means the last column is this one. Okay, so based on this one, design the model. We have to design the model. All right. So what I have to do? GF equal to data frame equal to PD dot read underscore csv housing dot data, the file name housing dot data, and check df dot head. What happened this? Check this one. The first problem. The first row shifted in header because there is no header. I check you this thing. There is no header. So pandas what do? It is automatically shifted first row in header by assuming this is my header. But this is not. So when you encounter this kind of case, put header equal to none. So this will let the pandas know that there is a no header in the data set. So what it do? It do the indexing of numeric 1 to 0, 1, 2, 3, 4, 5, 6 numeric indexing. Again problem arising because it have no comma so that we can split out the data set because there is only space is there. Space, definite space is there. Check this one. So in this case, what we do, we take one more attribute, delim underscore white spaces equal to true. Alright, when you put this thing, so I told that my delimiter is my white spaces. So it automatically count the white spaces and the split all the columns. Now check. 0 to 13, there are 14 columns. Right, I put this syntax. Alright, you can copy this one. This is my regression. Alright. Now, when we have this kind of thing, so we have to attach the column name. So do one thing, attaching the column. A double T. Okay. Attaching a column. So what I do over here, I take a list over here where I put all the columns, like 13 column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 was there. 0 to 13, that is 14. Alright. So where's my column name? Gone there and copy one by one. I will share you, no problem. You just stay over there. Mind the step, there is a no extra space should be. I just copy one by one. NOx. One is remaining. Okay. That is MATV. Median value in per $1,000. Alright. So I am getting this one. Control A, Control C. Get this from here. Okay. So when we have a list of this one, so what we have to apply the column, apply the column to data frame. All right. So what I do, df dot columns equal to my list call. Now df dot head, check this one. All the column are arranged beautifully. A data set is prepared. Now get the information about the data set. Df dot info, the first method, which give you the status about null, not null values. So we have 506 entries. All as my data set is full. Some of float, some of in only two in int, id and chas. All right. Now df dot is null dot sum. Check anything about the null value. No. Perfect. Everything is fulfilled. Df dot describe some statistical information. Check this thing one by one. So my crime starting from this values and maximum value is 88. Similarly, the value of Zn 0 to something what 100. Similarly, Indus this one. So all the statistical information about the mean, standard deviation, all the calculated over here for a given data set. These things are very useful when we do the single prediction when model is trained. So which parameter, which positive parameter, which negative parameter give me what kind of result, that is matter there. Okay, so keep this thing in your mind, how we do the prediction, single prediction by putting the input result. Okay, now
Sir,
yes please.
sir, can I ask you?
Yes yes
सर
yes
ये
yes
df डॉट इजनल डॉट साम ये क्या शो कर रहा है?
बेटा
कोई
सबसे
लाल
पहला नहीं
फंक्शन
नहीं
है
नहीं,
ये?
नल फंक्शन क्या
लाल
करता है?
वाली?
नल वैल्यू मीन्स ये होता है अगर कोई नल वैल्यू होती है किसी कॉलम में, ब्लैंक होता है आपकी एक्सेल शीट में, तो वहाँ ट्रू रिप्रेजेंट करता है वहाँ पे। अब देखो ट्रू ट्रू कहीं नहीं है, फॉल्स हर जगह, मीन्स एवरीथिंग इज फुल।
हाँ,
Beside looking this
अच्छा,
table, beside this dangerous table, okay, I just put sum. It will count only those value which are true, but no way is true. If you go on through the pandas lecture, I give you the nba data set, you find the null value over there. Okay, so anything is null value, it will show you 1 2 3 4 5 6. Just like nba, sometimes it's the sadly shows the 84 null values, sometimes college 11 values. Okay, so means my data is full, no null value are there. Is, see, every method in python if having a is before this, it means it's a questioning to you. So when you have a question, so either you say yes or not. Yes means true, not means false. All right.
Sir,
Yeah.
sir, I have a question.
Yes sir.
If dot describe, uh, can you uh, press the or shift and tab under df dot describe function?
No, no, repeat what I do this thing.
Yeah, can you press under df dot describe shift dot tab?
Shift dot tab.
Yes, yes. There is a parameter percentiles.
Mhm.
How to do it?
So but do this percentile is equal to yes. I mean I never use the percentile because percentile confuse you. Why confuse you? Somewhere I see sometimes.
No, I.
Why it is
With
confusing, I'm telling, please wait, I'm telling why it is confusing when you put the single prediction. So you have to see if this attribute is a negative slope, so from where to where your model is trained for the value. So percentile give you whole view but not value. Okay, so percentile I just try to put over here. Percentile, what we have to put, true or false?
true.
Nothing is,
I don't know actually.
never I
That's why
use the percentile, I mean because
I
when you
tried.
want, when you
Tried
want to
but it's not working.
search on the google, meanwhile okay we are doing this thing google, okay at the end, because at the end I have used this thing very much, from where to where my crime values moving, and in prediction part if I increasing my crime value, so what is impact, house price is increasing or decreasing. That's the thing which I want to show, and that's the thing which not happen with the help of percentile, only with the value. All right. Now moving, describe is now histogram part. Okay, so what I do all the histogram. Plt dot figure. How many column we have? One, two, three, four, 14 columns. So 14 column arranged in 4 rows, 4 columns. Yes, perfect. Plt dot figure fixed size. Hmm, Fixed size. I take the 12 by 12. That is perfect. If necessary, I will take. So for I range range of length of call, right? Call. Then what I do? I do the subplot. Plt dot subplot. Plt dot subplot. 4 rows, 4 column. Then I plus one will be a parameter. Now, with the help of this one, SNS dot dist plot. What I do for this, I have to take call of I, means anything which is available in the column. Okay, then we have to embed this thing inside the df call of I, then hist equal to false. All right, then yeah, then plt dot show. Let's see the distribution of data. What happened? Plt dot subplot plot. All right, all right, we have to put the kd equal to false, not hist equal to false. Kd equal to false, then it will give you the histogram. Yes, okay, let's see the interpretation. Mostly a city is my crime free city, because in mostly city my crime is zero, and then later on it is little bit increase. See, in India also you can see the mostly city is not crime free, little bit crime is there. Okay, then see the charts. Analyze this one. Either some cities around the charge is a river, so either majorly cities not located side by the city, river, but some city is located side by the city, river. Okay, so zero means for not located, one means the located. Okay, move further. NOx, mostly city have a less pollution, but some city have a higher pollution. All right, this is perfect term, room dwelling, perfect distribution. Okay, now age. In my data set, mostly person are aged. They are attending the age of 100, and they are very high. Means they are ready to move to their children's. They are not living in their house. They are trying to selling their house because they are aged one. I mean, the practically true. When the parents get old, so they are trying to leave the house at any cost and living inside the children's. Now, PT ratio. Check this one. Some city has a higher people teacher ratio. Higher people teacher ratio. So what happened? That is not a good standards. Means every parents want to locate in that city. The medical facility and the educational facility is very good. Okay, so that is not over here. All right, and the house price, what is in MEDV, is also good distribution over here. So this is interpretation from the different parameters over here. Same way, if we do plot a regression plot, same using parameter regression plot. All right. Okay. So what we have to do? We have to SNS dot reg plot on x-axis. Sorry, on x-axis we have to put all data points. We have to put on data points. Call of I means column list E1 by 1. On Y we have to fix the last column because that is my outcome variable. Okay, and then we have next attributed data. Okay, so I recommend only the 13 plots because MEDV to MEDV is not recommended. Check this one, what is returning to me. Yes, perfect, perfect. Okay, let's see this one. See the slope also. Negative slope. As the crime increases, house price decreases. Positive slope. As the Z increases, house price also increases. Negative slope. Negative slope. Positive slope. Okay, again NOx, the pollution. Negative slope means as the pollution increases, house price decreases. Room dwelling, perfect correlation over there. Okay, and uh, PT ratio. As a teacher people ratio is increases, okay, so house price is going to be decrease. Okay, again the MEDV is not there. So at last, when we got this prediction, we do the side by side the predicted line also plotted. All right. Now extract features in the given data set.
Sir, what about the PT teacher ratio, sir?
Pe-
How
People teacher ratio,
as
people
it increases and that house price is
is going to
decreasing?
decrease according to data set. House price going to decreases.
Why, sir? Like general idea. I'm not asking like an
Mm-hmm.
absolute.
Uh, why it is putting? I mean, what inside data set? I don't know, but it shows the. If you see, let's go the documentation. People teacher ratio by town. So either it says same way, same explanation. One teacher have a less students, so good education standard. It's increasing, and the plot is going to be decreased. Either we are interpreting wrong way, but 15 PT ratio means ratio means what? One teacher, how many student?
Upon 15 students,
15. Okay. So what is the fraction of this one? One student,
one teacher.
one teacher, and 20 student. Which fraction give you lots of thing. This is lowering down much. So according to this one, this is up. This is up.
I can see the
Yeah.
correlation is weak, it's not strong.
Uh, Maybe correlation. You can go to correlation matrix. You can find over there. Okay. Because here the motive behind to create a model. Okay. So this is good question. I mean, it should be positive. Mm,
Because as the number of teacher will be increases up for like there will be one teacher of 20 students.
means we are increasing the number of student. Increasing number of students. So yes, same thing. Good thing. Savisachi, good, good. I got it. If you have a loss less student, okay,
Yes.
so house price is high. If you have a more student, so house price is low. Means
Oh, yes,
you are locating in that city which are cheaper. There is no my education standard. Just like in Delhi, you are purchasing house in Delhi and you are purchasing house the Meerut. Okay,
okay.
so little bit
Yes,
thing. So less student means more price. Now you can interpret like this.
yes, sir. Yes, sir.
Okay, that's why if the thing PT ratio student is increasing, then house price that's why decreasing. That's the minus slope. Okay, I mean researchers do this thing very carefully. We cannot blame the researcher. Okay, all right. Okay, okay. Now extract all the input feature. Extract all the input columns. Columns means we are taking x1, x2, x3. All right. So what we do for this? I take keep in mind every time, everywhere, data science, machine learning, deep learning. The inputs feature always store in x. Sometimes you find the capital X, sometimes you find a small x. That is not matter. But x is matter because equation y equal to mx plus c says the inputs are residing in the x. So what we do over here, df dot ILOC function, all the rows, comma, 0 to 13 columns, except, first of all, I have to put over here df dot head so that you can easily crop this one. There are various approach to find this one. I'm telling you easiest one. Take this column as a input, output. Okay. So x equal to df dot ILOC, all rows from 0 to 13 columns, x dot head. Yeah, perfect. MEDV is removed. Similarly, the next one is response vector or outcome. Sometimes response, RESPONSC, response vector is a single column or outcome column. I have to store this thing in Y, only one column. Sometimes I just put 13 onwards, no column is there, so it will only capture the single one, MEDB, in tabular format. Both are two-dimensional matrix. So inputs are there, output are there. Now, one more concept. If we have a data set, these are my X part, that is inputs, that is my output. Then we have to split one more way, that is training, and that is testing. According to your convenience, you can put train part 60% of data set and test part 40% of data set. Okay, so now each variable is split into two parts: X train, Y train, X test, Y test. Okay, and one more thing, sometimes you play the cards game. You shuffle the cards before distributing to each participant. Why? Because all good cards, Ikka, Basha, Gulam, Begum, not one goes to one participant. They are equally distributed. So for this one, we have to shuffle this data set. So I have to use a train test split. Train test split. What I do for this? I use the model selection library from sklearn dot model selection. Import train test split. It will automatically give you the partition of data when you do this thing. I generate four variable: X train, X test, Y train, Y test, train, Y test, equal to train test split. This is class over there. This is now constructor over there. It take X. What it do with X? It will split X into two parts: X train and X test. Similarly, it take Y. It take the test size. Means what test size you are preferring. I take test size equal to 0.4. 0.4 is corresponding to 40%. Is corresponding to 40%. Because 1 is for 100%. So keep in mind 40% testing size. So remaining trading size will be automatically 60%. And then one more variable, random state. What is that? That is for shuffling. You can put any number, and that is internal algorithm of scikit-learn. I number 6, 16, 5, 1, 2. So that is used for shuffle. Okay, let's see. If we have the X train data set and want to check its head section, so it do partition but see the indexes. It do shuffle the data. Alright. Now what is about size? X train dot shape. Initially it's a 506 row. So training consumes the 60%. So what about the testing? Dot shape. That is remaining 40%. So 506 rows is split into 303 and 203. That is given 506 rows. So where I got the 506 rows? In description, I got the 506 rows. Alright. Now load the linear regression model. How we load this thing? What we do? From sklearn dot linear model import.
Sir,
Yes, please.
sir, is there any difference in train and testing, sir?
No difference. We used training data for train the model. We use test data to evaluate the model. Nothing else. You have a data. You do shuffle. You take 60% for training. Just like you cover some syllabus in your semester. Okay. So teacher taught you, teacher train you, and on give some syllabus, it take the test as a semester examination. The same thing apply over here. We do train the model, and then later on we do test the model on test data.
Sir, I have read somewhere that in training data set we know the y variable, but in testing we don't know the
Mm,
y.
y variable means, what does it mean of y variable? Y variate means no. As
Means we like say supervised, unsupervised, like
this
we
is
know the outcome. In
this is a supervised learning. This is supervised learning. At regression is part of supervised learning. But you have data sets, so why you don't know? Yeah, you don't know what data is coming futures, but real time data. But the data set you have, you can know what inside that. If you don't know how to set the parameter, everything over there.
Sir,
Yes.
sir, actually, sometimes validation is also there. So she is
Mm,
talking about something like that, I think.
see,
So,
validation. See, two things are there. One is cross validation, one is validation. Validation part is only artificial neural network. Nowhere else. We have training and testing only. Okay. Sometimes in machine learning, we say testing part is the validation part. Sometimes, but explicitly validation part in artificial neural network. They train the thing, they validate the thing parallelly. Okay. So training, validation, testing is these three different things. Artificial neural network, but training and validation and testing is same thing in the machine learning. Okay. So lots of things are available in internet, so don't be confused. Means confusion creates a problem. Okay. So see first how the model is building. Then we take model equal to, means step one, create model variable. How? Model equal to, calling the constructor of linear regression, fit the train data. Fit train data. What we do? Model dot fit x train, comma y train. Then got the prediction. I take the pred. Step 3, this is step 2, step2, get prediction on test data. P-R, P-R-I-D-E, where is spelling more wrong? P-R-I-D-I-C-T. Where is spelling wrong? P-R-I-D-I-C-T. P-R-E, what is spelling of predict? P-R-E, when I point spelling very especially,
sir,
P-R-I-D-C-T.
PRED.
Yeah, P-R-E-D-I-C-T, yes, on test data. So pred equal to model dot predict. No, why it's not working?
the PREDICT.
Let's see, it's give you error. Okay, so what the important thing? What I pass over here? I have to pass over here y test. Why? Why I have to pass here y test? If you gone through the slide, okay. So the thing which are we calculated over here? Check this one. We are using the actual value, and corresponding actual value. We are getting the predicted value. Okay, the same thing I'm passing over here. I pass this thing over tested data. So I passed over here y test. All right.
Sir, it should be X test actually.
Yes, sorry, X test. Okay. So what it returning? This will returning the prediction. This will returning the prediction comparable to y test. So y test is my actual value and prediction is my equivalent value. So if you want to see over here, nothing is understandable. So let's do the side by side comparison. What the parameters? What are the input parameter? What is the actual prediction? What is the what is the actual value? What is the prediction? So what I do, I have data in my X test or input data. Then we understand better. All right. So what I do, I take one more data frame, result. Result equal to X test. I'm adding two columns. One is actual, result, actual, actual. What I put over here, actual we have Y test, then result, same data frame. I'm adding one more column, predicted. Okay, that contain my pred result. Now you can see the result dot head. I'm taking the 20 rows. Now these are your inputs. Based on these inputs, my house price is coming 15, but predicted value is very high. Based on this input, house price is this one, but this is nearby this one. Based on this one, so here what I do the side by side comparison. These are actual values and these are the predicted value. Okay, if you want to write this data frame, so take result dot to CSV, take my prediction dot CSV. When you run this cell, so the root folder where you contain this Jupyter, you got this over here. When you open this Excel, my Office Excel, so it will open properly row and column format. All right. Now this is where you how to go to prediction model. Do predict, there is a predictive modeling, but how we compare this thing visually, just like we do over here. This one. Okay, one is line for actual, one is line for predicted. Okay, so what I do, I take two regression plot. First, pick the column. My data is my result. Okay, on y we have, what we have here, actual. Now MEDV is removed, everything remaining fine. Call. Okay, data is one more thing. I'm just taking, actually one more thing, label also take, label equal to actual. Okay, so now finally here we have to take pred. In same column, I'm not getting this thing. Next time I'm getting this thing, pred label equal to predicted. Yes, hope so it will run. Then plt.legend. It's working two time. Now see the thing. Yellow line is actual line, predicted line is yellow line is predicted line, blue line is actual line. So your approximately all the values, all the blue and yellow lines just overlapping means you have a good model everywhere, everywhere, everywhere. So we are not following here the all concept of machine learning. We are just focusing on the model, predictive modeling, how to train the values, how to think the thing, and how we got the prediction on different parameter. Each parameter. Blue line is actual line, line is predicted line. That's all for today.
Sir, don't we check R score value?
There are something we have to check the machine learning part. Okay, lots of things I'm missing over here. That is part of machine. R2 score, correlation matrix. You want to check it right now?
Yes, sir. Just
Okay,
like
okay,
I
okay,
said,
okay.
so
From
like
okay, okay. Sklearn dot matrices import.
सर ये लास्ट कोड एक
वेट
बार
वेट
दिखाइए
वेट
ना
वेट
थोड़ा
वेट
सा ऊपर कीजिए ना
वेट
स्क्रीन
वेट सुनो जब एक क्वेश्चन चल रहा हो तो आपने वेट किया करो टैट का हाँ वेट आर टू स्कोर सो आर टू स्कोर we take the y test and pred sorry it's a pred not bad it's good 68% good model that's why all the lines are nearby got it. All the evaluation metrics we keep for the machine learning part lots of things missing but today's focus on the predict how we create a model now you can
yes,
check. I will share this code because maybe you do the typing mistakes. You guys do this thing. We are meeting on Sunday 11 a.m. Anyone do have some problem regarding this one? See, this concept extend infinite limit. Okay, because many things are missing, but that key thing I put for the machine learning part because something I have to teach you in machine learning. But data analytics part, being a data analytics part, is a predictive modeling. How to get data, how to train the model like that, and then we how to got the prediction over there. All right, sir.
Sir, are we done with data
Sure.
module?
Please repeat the question.
I'm saying that are we done with the data analytics module?
Little bit thing is remaining because not all topics are covering live classes. I will cover some selected topics. Maybe I will teach you the classification and image processing mm, in data analytics part.
Sir, I want to know about the test, like t-test.
Actually, not all topics can be covered in live classes. I have to talk with management first. Okay, then because the LMS given to you, LMS is given to you, so you can read out over there. Okay, if beside this you getting the problem, mail me. I will clarify. I will try to make this thing on Sundays like that. Tomorrow we
Oh,
don't have class. All right. Tomorrow we don't have class. We have class. Doubt class on Sunday. Next class on Monday.
okay. Thank
Okay.
you.
Thank you so much, dear. I am very hungry. So I hope you are also very hungry. Any
Hello.
more? Yeah. Any more question? Yes, Shweta.
So this is Shweta.
Yeah.
Actually, I wasn't able to attend the sessions from 25th. So, could you please tell me whether all the sessions are uploaded on
Yeah.
YouTube or something is
Yes. Yes.
missing?
Yes. Yes. Something. Everything is uploaded. Everything is uploaded. So you please go and check the date. I mean the 25th session upload on the 26th. So
Okay.
someday I take the holiday because I was in a fever, little bit fever, so I take the holiday. I don't know which is 26th or 25th.
Okay.
Because you gone through that the upload date is displayed on YouTube. Okay, so
Yes, sir.
that the thing.
Okay. Okay.
Thank you so much, students.
Thank
Where's
you,
my?
sir. Thank
Thank
you.
you. Good night.
Hello, sir,
Yes,
before this
yes,
side.
before, yes, before,
Hello.
yes, before. हाँ क्या हुआ बताओ.
सर, ये सर आर स्क्वायर में एक्चुअल वैल्यू और प्रिडिक्टेड वैल्यू दोनों सेम आ जाता है क्या, मतलब आर स्क्वायर?
नहीं नहीं एवरेज वैल्यू प्रेडिक्टिव वैल्यू का रेशियो देखते हैं ना इसमें. इसमें अगर 1 के अराउंड आ रहा है आपका, इफ 1 के अराउंड
अच्छा,
आ
ये
रहा है तो आपका मॉडल उतना ही एक्यूरेट है. ये 68% एक्यूरेट मॉडल यू कैन से दिस थिंग.
ओके
Any
ओके।
prediction written by this model, I mean I don't give you the single prediction.
वन से नीचे ही रहना चाहिए ना आर स्क्वायर का, अगर वन
वन
से
से
नीचे
नीचे
रहेगा
नहीं,
तो
वन से नीचे नहीं मीन्स ये वन तो कभी आएगा ही नहीं पहली चीज।
मतलब जीरो से वन के बीच में ही रहेगा।
ये माइनस भी आता है जब मैं क्रॉस वैलिडेशन पढ़ाऊंगा ना। तो इंडिविजुअल फोल्ड का R2 स्कोर निकालते हैं। तो जहाँ पे बैड डेटा होता है ना, कोई कोरिलेशन नहीं होता डेटा में, वहाँ पे ये R माइनस रिटर्न करता है। Okay, but that is a part of cross validation part of machine learning. So there I will show you how each layer return you to auto score. So what happened, in which fold you have a good data, but ultimately if you want to prepare the model you have to shuffle the data. आवाज गई तुम्हारी, आवाज सही करो, आवाज अपनी 31 सेल में, हाँ ठीक है। दिस इज 31।
या सर ये हाँ सर, इसमें एक्स को हम लोग ट्रेन कर रहे हैं, मतलब एक्स मॉडल को मॉडल एक्स को हम लोग ट्रेन कर रहे हैं और वाई प्रेडिक्ट हो रहा है, तो मतलब एक्स हम लोग को पता है क्या है।
नो, यू आर लिटिल बिट रॉन्ग। हम लोग क्या कर रहे हैं कि मैंने आपको चार्ट दिखाया था। जो मैंने पीपीटी दी थी उसमें सब चीज़ कंबाइन अप्रोच है ना। मुझे एक्स की वैल्यू पता थी, मैंने उसी पे मॉडल ट्रेन किया, उसी पे प्रिडिक्शन निकाल ली। हाँ, अब मैंने यहाँ क्या काम किया ध्यान से देखना। मैंने क्या काम किया, मैंने अपने डेटा सेट को डिवाइड किया ट्रेन और टेस्ट में। ये मेरा डेटा सेट है, मेरा एक्स वाई है, ये एक्स ट्रेन है, ध्यान से देखना, ये वाई ट्रेन है, ये मेरा ट्रेनिंग पार्ट हो गया। इस पर ट्रेनिंग दे दी मैंने कहा भैया ये मेरा इनपुट है, मेरा आउटपुट, लर्न कर लो फटाफट से। ठीक है, फिर मैंने इसे दिया प्रिडिक्शन के लिए, एक्स टेस्ट मैंने दिया प्रिडिक्शन के लिए, एक्स टेस्ट दिया। इसने क्या किया, प्रिडिक्शन रिटर्न करी। इसने क्या किया, मुझे प्रिडिक्शन रिटर्न करी जो कि वाई टेस्ट के इक्वलेंट थी। ये प्रिडिक्शन रिटर्न की वाई टेस्ट के इक्वलेंट थी। तो मैंने एक्स टेस्ट पास किया, प्रिडिक्शन ली, उसका मैंने इन दोनों को कंपेयर किया, जो मेरी एक्चुअल वैल्यू थी, जो मेरी प्रिडिक्टेड वैल्यू थी। उसी वैल्यू को दिखाने के लिए मैंने ये चार्ट बनाया कि जब मेरी दो चीजें आ रही हैं तो कहाँ मेरा एक्चुअल वैल्यू लाई कर रहा है, कहाँ मेरा प्रिडिक्टेड वैल्यू लाई कर रहा है। हाँ तो अरे तो यही तो चाहिए कि आपकी प्रिडिक्टेड वैल्यू एक्चुअल वैल्यू के पास आ रही है। हाँ हाँ, मैं आपकी आवाज बहुत धीमी आ रही है, तो अच्छी बात है ना ये तो। आपकी एक्चुअल वैल्यू प्रिडिक्टेड वैल्यू के पास आ रही है। आप ये देखो जरा, मेरी स्लाइड आपने ध्यान से देखी नहीं, ये स्लाइड में दिखा रहा हूँ। यहाँ क्या हो रहा है, सारी प्रिडिक्टेड वैल्यू दूर आ रही है। आपको ये नहीं चाहिए, आपको चाहिए कि आपकी जो ट्रेनिंग वाली लाइन है वही प्रिडिक्टेड के ऊपर ओवरलैप करे। तो जो आप चीज पा रहे हो, अच्छी चीज पा रहे हो, ये दोनों चीज ओवरलैप करनी चाहिए। जितनी नियर बाई उतना बढ़िया है। ऊपर नीचे होगी तो प्रॉब्लम क्रिएट करेगी। बट मोस्टली थिंग्स आर ओवरलैप, मींस योर प्रिडिक्टेड वैल्यू नियर बाई द एक्चुअल वैल्यू। आपकी एक्चुअल एज, प्लीज पुट योर हेडसेट, आपकी एक्चुअल एज 20 ईयर्स है। आपका मॉडल प्रिडिक्ट कर रहा है इधर 21 और 19, सो बढ़िया बात है नहीं है। अगर ये 50 प्रिडिक्ट करे तो कैसे रहेगा, गलत मॉडल होगा।
Okay.
ओके, सो दीज आर नियर बाई द थिंग्स।
Okay, sir. Okay. Okay. Okay, sir. Thank you.
थैंक यू डियर, गुड
सर
नाइट।
सर सुधांशु
हाँ
हियर।
सुधांशु बेटा बताओ।
सर आपको एक बार रिपीट नोटबुक में चाहिए,
जी बताइए।
नीचे पूरा एंड में आइए सर, एक खाली टैब में।
हम्म,
सर आप यहाँ पे मॉडल डॉट स्कोर लिखिए एक बार।
सेम चीज है।
स्कोर ब्रैकेट में एक्स कॉमा वाई लिखिए सर।
एक्स है इसमें, चलो।
एक्स कॉमा
अच्छा
वाई
अच्छा, हाँ
लिखिए।
अच्छा, तुमने वो कर लिया, ठीक है।
ये आंसर ये क्या है सर, 73%, ये क्या बता
ये
रहा है?
इसमें तुमने पूरे उस पे लगा दिया ना, तुमने पूरे इसमें लगा दिया, क्या कहते हैं, पूरे डेटा पे लगा दिया। अब इसमें, अब ये क्यों लगा रहा है, यहाँ क्यों लगा रहा है, क्योंकि ये टेस्टिंग डेटा है। इसमें वो पॉइंट इंक्लूड नहीं जो इसमें सारे पॉइंट इंक्लूड है।
ओके,
जिसमें
मतलब
वो
मेरा
पॉइंट,
पूरा मॉडल का देखा जाए तो
हाँ
73।
ये चीज तब काम आएगी ना जब तुम ओवरफिटिंग पढ़ोगे, कि पूरा मॉडल क्या रिएक्ट कर रहा है, ट्रेनिंग पार्ट क्या रिएक्ट कर रहा है, और टेस्टिंग पार्ट क्या रिएक्ट कर रहा है। तभी तो
लेकिन
डिसाइड।
ये लेकिन कितने है मेरा मॉडल का एक्यूरेसी
ये
जैसे,
पूरे मॉडल की निकाल दी तुमने, है ना।
अगर अगर मैं जैसे कि मेरा ये यहाँ पे यहाँ तो सिर्फ एक्स है,
हम्म,
लेकिन अगर मैं एक्स को अगर पर्टिकुलर फीचर सेलेक्ट कर रहा हूँ उसके बाद ये मेरा मॉडल बन रहा है, तो वो एक्यूरेसी उस मॉडल के हिसाब से
एक
देगा
मिनट
ये।
एक मिनट जरा रुकना, मैं एक चीज़ और करके देखूँ कि मैंने स्टैक ओवरफ्लो पढ़ा था, दोनों सेम चीज़ आती है कभी कभी। नो नो, ये नहीं दे रहा, इसमें इसमें नहीं दे रहा, इसमें नहीं दे रहा है ना। तो ये
सर
क्रॉस, ये उसमें तब आएगा कॉन्सेप्ट, आपका ओवरफिटिंग वाले कॉन्सेप्ट बहुत कम आएगा, ये फंक्शन वाला।
सुधांशु सर, एक चीज मैं ऐड करना चाहता हूँ यहाँ पे,
बताओ
ये जो
बताओ बताओ।
आप निकल रहे हो यहाँ पे, आप डेटा को ट्रेन टेस्ट स्प्लिट करके अलग किए हो। लेकिन सर कभी कभी कुछ कुछ डेटा, जो सपोज कैगल से कोई डेटा उठाया, वहाँ पे सपोज कुछ डेटा अलग से रहता है, ट्रेन डेटा अलग से
वहाँ तो
रहता है।
फाइल अलग ही रहती है, वहाँ ट्रेनिंग अलग फाइल रहती है, टेस्टिंग फाइल अलग रहती है वहाँ
हाँ, तो ट्रेन के ऊपर जब वो वाला फाइल में आप हम लोग करेंगे, तब तो ये मॉडल थोड़ी देखेंगे ना डायरेक्ट, वहाँ पे तो हम लोग ट्रेनिंग डेटा के ऊपर काम कर रहे हैं।
तो।
हमारा हमारा इस केस में हमारा मॉडल ही तो एक पर्टिकुलर मॉडल आप बनाए हो ना सर।
हम्म
I mean,
हम्म
आप इस मॉडल के ऊपर फिट कर रहे हो, बाद में आर स्क्वायर चेक कर रहे हैं ना सर हम लोग को। आर स्क्वायर ये बता रहा है कि हमारा जो वेरिएबल है, जो फीचर है, वो टारगेट वेरिएबल्स पे कितना इफेक्ट करने का उसका पावर है ना सर। आई
एक
मीन
मिनट रुकना, एक मिनट
अगर
रुकना
0 से
तुमने।
1 तक है अगर, तो कितना हाईली इफेक्टिव है टारगेट वेरिएबल
एक
पे।
मिनट रुकना, एक मिनट रुको, यहाँ पे मैंने एक्स्ट्रा ट्रेन किया, ये किया। अच्छा, अब देखो डिफरेंट डिफरेंट चीज़ें देखो, चीज़ देखो वाई।
एक चीज मैं कहना चाह रहा था कि ट्रेन डेटा जब हमारे पास रहेंगे, तो हम लोग ट्रेन डेटा के ऊपर ही चेक करूंगा अर्थ तक को, क्योंकि
क्योंकि उसमें उसमें जिस टाइप की ट्रेनिंग दे दी है तुम्हें, उस टाइप का ही तुम्हारा निकल के आ जाएगा। एक्स टेस्ट वाई टेस्ट ये इस पे ही दे रहा है, एक्स ट्रेन वाई ट्रेन पे दे रहा है, इस पे नहीं दे रहा है ये। हम्म
हाँ हाँ हाँ। सर वाई टेस्ट की जगह पे प्रेड लिखिए सर एक बार।
वाई टेस्ट की जगह पे प्रेड। Nothing else error. Okay, no problem. We will discuss in that session when we do the overfitting. That function will work in that sense. Okay, because each thing will we have to see what is it training error. उसमें overfitting में क्या होता है, ये देखना होता है ट्रेनिंग errors कितनी कम जा रही है, टेस्टिंग errors कितनी ज्यादा आ रही है। तो ये चीजें,
ये जो प्रेड है सर, ये एरे फॉर्म में है ना सर। आई मीन
हाथों से
एक
चेंज कर लेंगे
डेटा
इसको,
फ्रेम में इसलिए नहीं आया सर।
रीशेप कर लो या फिर उसे वो कर लो, क्या कहते हैं, फ्लैटन कर लो, तो काम हो जाएगा, ठीक है ना।
ठीक है।
ओके, गुड नाइट डियर।
थैंक यू सर, थैंक यू।
हाँ